Hi there, my name's Adham, and I'm here to introduce my team members, Lloyd, Mayank and Aurelio. We are Project 17, and to start us off here, I'll be discussing our project, our goals, our objectives. Initially, we were asked by our client, the Maribyrnong City Council, to provide them with a web application that will show future predictions and generate a heat map alongside graphs, which will be further discussed by my peers later on through this video. First, I will just begin with the general UI, starting off here. Here we have 11 sensors surrounding into the Footscray CBD, as you can see here, ranging from the West Footscray Library to the Footscray Park Gardens and then the Nicholas Street campus at Victoria University. Alongside these locations, we have the many different bus stops and tram stops. And also, to further amplify the graphical interface here, we have a light mode and a detailed mode in which the user, public or client, may be able to dictate where a bus stop is or where a sensor is near maybe their closest commercial venue. On the left side here, we have a panel and also a heat map info box dictating the seasons, date, time, and type. At this current moment, the data is not filtered, so there's no information inputted by the user. Therefore, it's all default, NA, default map, all, and pedestrian. On the left side here in the left panel, we have the different locations ranging from 1 to 11, from the Footscray Library car park to the West Footscray Library. And if we switch it to the filters section, here we have the input for the user with various fields from traffic type, date, time, year, and season. Alongside two buttons, a generate heat map and a reset filter. At the very top here, we have an export function and then we have a menu function. As you can see, when you highlight over one of these functions, it will glow with a yellow, which will indicate that the user, upon selection, will enter that field. Let's give a demonstration here. Let's select a traffic type, for example, vehicle count, and a date. Let's just say the 7th of March. We'll provide a time also. Let's go to 12 p.m. and then we'll generate a heat map. On normal, it takes about 1.6 seconds for a heat map to generate. Here we have the different locations. As you can see, everything is color-coded. So heavier traffic will be a darker shade of red, and then a lighter sense of traffic will be a lighter shade of red. Due to it being a vehicle count, and there are two sensors here in Footscray Park Gardens and Footscray Park Rowing Club, obviously there are no vehicles that come across there, so the fields are both null. As you can see, the locations are surrounded by the bus stops and tram stations, so this provides the user essentially a detailed location. So perhaps one day an individual wants to take a bus stop, he gets an idea as to the time and how much traffic is in that area, and maybe they dictate that and choose which bus stop they want to go to and arrive at. When you hover over one of the locations, you're provided with the location's details. Again, it's type, which in this case is a vehicle, a count. For Snap Fitness here, it's 278, and then a date, a time, which is what we selected in the filters, and then a season is produced, weather is produced, and temperature is produced. After this, you can go back to the list section on the left here, in which you're provided with the same amount of information listed under each location. As you can see here, when I open up multiple, here in the search locations bar, you're able to filter it out to find your specific location. Oh, there you go. For example, I've just typed in Footscray LI, which produces two different options, Footscray Library Car Park, which then shows the type, count, date, time, season, weather, and temperature, and also the Footscray West Footscray Library. I'll pass it on to my peer now, who will talk to you about the dashboard.
Hi, my name is Lloyd, and I'll be going through the functionality of our dashboard here. So as you can see, over here on the top is the left and right arrow. As you can see, these will pretty much transition you to the dashboard. So This will display the data visualizations of the whatever was filtered through. So in this instance, it's the vehicle count of 2024, 3rd of March 7th at 12 o'clock. So in this bar chart, we'll pretty much display all of the sensor data for the whole day. So as you can see, it's just the total counts of the traffic for that period. So it just shows all the sensors on the x-axis and the traffic counts on the y-axis there. You can also filter it by the total count as well here. So this will give you the total count of the locations for that day there. Then you also got your daily average. You can filter through for this bar chart. As you can see, it changes the bar chart there. You can also, because this was made with Plotly, this framework allows you to pretty much zoom into the chart if you need to. You can double click to zoom out as well. Okay. On the right here on this graph is the line chart. So this line chart is built on the same framework as well. So you can zoom in to it to really get a more concise view of the data you want from this line chart. Double click to zoom out. But this line chart will give you the overall interval counts throughout the whole day. So it's not just the hour, it's the whole day. And as you can see, on the x-axis is the time of day, so it is all separated by an hour interval. And it will go all the way up to 11 o'clock, which is pretty much till when the sensors reset the count, and it'll go back to 0. And you can filter this as well by the sensor that it is. So for example, we're already looking at the Footscray Library car park. We can filter it just to the Footscray Market, Irving Street and train station. So as you can see, it changes it already on the fly for you. Okay. The next chart I want to show you is the pie chart. So this one is similar to the line chart on the top right, but this one is practically showing all the traffic types within that day at that center. So for example here, right, we got the pedestrians in green, vehicles as purple, and cyclists as yellow. So you can also filter this by the sensor, okay? And you will, this will just show you the total count of that traffic type in that pie chart, and also will show the percentage of it. Lastly, the last chart here is our forecast chart or our data model. This is to forecast the predictions of the traffic counts from now until 2026 as shown here. So this is a linear regression. Just for now, this is just a kind of model in beta at the moment. We haven't integrated our latest version, but we'll go into that later on with Mayank. But for now, as you can see, this linear regression, right, is kind of sloping downwards. So it will show you just a kind of a trend line on the pretty much the prediction if it's going lower with the traffic counts, or if it's going to be higher, or if it's just going to stay pretty much the same level. And as always, you can filter this by the sensor location. Now, I do want to get into the export. So by clicking on export here, it exports all the charts and all the dashboard and the heat map into a singular HTML file. So you can grab all your data into one file here. So you can export it, print it to PDF if you need it. It will be static if you do print it to PDF, but this has any advantage for you if you want to put all your data into one section. I do want to go through the validations here. So the filters, not validations, just how dynamic our website is. So as you can see, when you move the window around, it does refresh a bit and move into a single display, okay? Not a single display, it will move the boxes and be aligned accordingly. So you're able to resize the windows as it is. Okay, we do have our loading. So every time you do move, unfortunately, it does have to reload all the graphs because it's still fetching it for you. But you do have the loading spinning there to just give you that it is loading through. Now, in regards to the buttons in the UI sidebar here, generate heat map will generate it for you. Okay, resetting the filters will reset everything to default as you entered the website. So if I just click it now for you, as you can see, it gives a kind of a snack bar alert on the bottom there, and it will reset everything to null, and you can then reset and fetch your dates again. Now there is a user validation here. If you click generate heat map, it will release that snack bar alert down there that you do need to put in the traffic, date, and time. These ones are required to generate your heat map and all the other data visualization there. Okay. Now, when you do generate a heat map here, okay, so when you generate it, as you can see, there is a loading bar that happens there to show the progress, and it will generate it there for you. Now, if you do change it on the fly with time, it will change it automatically for you. Same with vehicle and traffic type there. Okay. To the next, I believe that's all there is about the usability of our website here. Now, to get into this website on how it was made, okay, let's talk about a bit of our backend here. So as you can see, to run everything through, okay, we are using a local host for now for this. It does have the modularity where you can actually go into the config file and configure it to your own database, okay, for yourself. So it does have that modularity there. But for now, what we are using here is called XAMPP. We are using MySQL, okay? And as you can see, we are using PHP to pretty much use it as our database, okay? So to talk more about our backend and everything else, I will pass it over to my friend Aurelio.
Okay, hi, my name is Aurelio. I'll be talking about some of the technical stuff. First, we have the database. In here, we got the 5 tables, which include the heat maps, the process data, summary charge, traffic counts, and the weather season data. They all work in tandem with another, except for heat maps and the summary charge. Those are the result of the models and analysis. And going back to the backend, we've divided the technology into backend and front-end just to organize the files much better. So I'll start with the backend. We do have a server Flask. We're using Flask to deploy and serve and generate API, custom API that we call from the front end. So we got some blueprints here. We got for the heat map, I will show you the heat map routes. So here it has the API generate heat map that will take in the parameters date, time, and traffic type, and that will call the smart generate, which is in this file. Visualizers generate smart generate, and smart generate works with the generate heat map, which will create the heat map that we've seen before, like so. And the way it works, it uses MySQL to take in all the data, the traffic, the time, and the count, the interval count. And that will result in the heat map. And what the Smart Generate does is it will assign a background preprocessing thread to assign the weather and the temperature using the OpenMeteo API. And those functions are here in the temperature and the weather files. Right, and then for the details. Details will enable us to see the snapshots. We'll send the data. And it also has, so that has the API location snapshot, and it will take the same parameters, date, time, and traffic type. And that will result in the snapshot that I'll show you. Like so. And now we see we do have the temperature. There may be some issues at times. The weather is still undefined, but on some occasion it does still works. And for the, so we do also have the statistic routes here. Statistic routes has all the API calls for the chart visualizations, including the bar chart, line chart, the pie chart, and also the forecast, the prediction model. And each of those functions are declared in the analytics folder. Say, for example, we look at the daily line chart. It uses a combination of Plotly to generate it and MySQL to query the data. And there's a custom CSS included in that one as well. And that will result in the line chart. That one. And yeah, and the Flask server will have the folder paths and a means to serve the heat map to the front end. It does also have a course to enable Flutter to deploy iframe, an overlay of the HTML on top of that. And yes, and also want to include that the process of the backend also included the initialization of the database to clean to pre-process the raw data. And in the initialize DB, we have a query to run to create the database, including all the tables. And after that, we will pre-process it, removing missing data, time interpolations, and just cleans the raw data to prepare it for the process. That is in the pre-process PY. And yes, and moving to the front end, here we got the front end only consists of technically only one screen. In the UI, we got the traffic screen here. So the traffic screen has a sidebar, include the sidebar on the left and the index page, which is it's an index stack, which has the heat map and the database. So technically, this is just one page. It's just a few on top of another. And the sidebar has a list. It has two tabs, a list and a filters that users can change. And that is here. Index tag and the sidebar, traffic sidebar. We do have the tab, the tags, the list and the filters. And upon entering the website, the first step is list. And for the logic, we got the traffic logic here that will call the API, this API generate heat map, again from the backend routes, heat map routes. So that's that. API generate heat map. It takes in the date, time, and traffic type, and the same. And it will use a JSON format code, and it will be decoded in the backend. And in the server, it will serve it. It will serve the heat map, and that will be stored in the tools heat map view. So this will include the URL which will be passed into the traffic screen. Yeah. And we do have some more models that we've prepared, and I believe my peers, Mayank, will be able to explore more details on that. And thank you.
Hey everyone, my name is Mayank, and I'll be talking about the linear regression model and also the modeling pipeline, how we use profit as our modeling aspect to give out various statistics and give the prediction for upcoming years. Here in my project, this is the current files that haven't been implemented, but like Aurelio talked about the linear regression charts that we are working on, this is a more finer and a better version. Currently in production, linear regression PY. As we run the program, we can see that the locations are visible, so there is a choice of locations the user can access. They don't have to really type the whole location, they can just select by numbers, which is one. Let's go with Footscray Library Car Park. Choosing on to vehicle count. The start date here means accessing the database from a particular time set. So you can train the linear regression or provide a linear regression on the basis of a certain data set. So for example, if you want it from a 3 months aspect or for the whole year. Here we will be taking the entire data set. So for all the way from 4th of March 2024 to 4th of March 2025. And those are the default values, so you can just leave that empty. It will just take on the predefined values. The start time is once again from 12 overnight, whereas end time is 11:59. The forecast end year can vary from 2026 to up to 2029. We can select that on the user end as well, but as a default value, it stays at 2026 if no input is given. We can also select the month for the first forecast, 12 being the default value, which is December, and ranging from 1 to 12 for entire year. With that done, the linear regression gets initially saved in the results folder with specific timestamp to when it was generated with the date and time. Having a quick look to that. The linear regression Footscray Library Park is particularly labeled onto what was generated. Here we can see this is the cleaner version of the linear regression with feedback taken from our lecturers. It does also define a few statistics, example the R2 value, which indicates how well the model fits the data. MEE value, which is the mean absolute error, basically predicts the average error in original units. The RMSE, which is the root mean squared error, penalizing even larger errors. So if there are any errors in the data sets that get notified on this aspect, and N is the number of data points that were used. We do had to deal with a lot of data points as it was seen in the previous video, in the previous presentation. But to make it more cleaner version, we had to represent less number of data points, but in the back end, it still runs through the entire year with all the data points in the data set. As you can see, the red line actually demonstrates the linear fit, which is the average for all the observed points. And moving down to after March 2025, we see a forecast of each and every single day for vehicle count in the Footscray Library Car Park. Moving on to our model, taking on feedback from the lecturer, we did happen to separate the model from the linear regression. Something I would like to highlight before we move on to the model is this is a looped source code. So if the user did want to generate another linear regression or another prediction model, they can simply do that by pressing yes or no. If I go yes, I would also like to show that the Footscray Park Garden and Footscray Park Rowing Club have error handling method similarly to the UI design. So if we go Footscray Park Gardens and select vehicle count, we can see it just displays no data available for vehicle count at Footscray Park Garden. Please select another location, looping it back to the selection menu. Exiting that, we move on to our model. A model.py file uses the profit forecast to determine and train itself. We train the model 3 times before executing the output. It can generate up to 5 different interactive charts and also provides a CSV file with all the results for data collections. Here we will be running the model file. Very similar interface to how the linear regression works. Once again, choosing Footscray Library Car Park, vehicle count, once again, selecting the data set, which is the start date, keeping it once again similar to the entire year, end date, start time, end time, and the forecast is once again 2026 all the way to December 2026. The forecast itself takes about 10 to 15 seconds to generate all the 5 charts, including the CSV file with traffic data. They once again get saved into results folder with specific timestamp with and date. Here we can have a look at all the 5 interactive charts, showing you one by one, going through what each chart represents, and also giving you a later summary of how the program actually works in the backend. So looking at, we can zoom in and zoom out of the graph. We are talking about how each and every day it has a Y mean value. So for example, 24th of August 2024, we are looking at about 8,678, but and once again it gets resetted to 0, which is the interval count. Moving on to our second chart. The second chart is actually a forecast chart, which is used by professionals to determine what is the best time for recording the forecast. We do have an upper bound on each and every single date from the data sets provided, whereas we also have a forecast of each date. We also tend to have a lower bound. The lower bound once again goes that we have a minimum, at least minimum number of vehicles passing from Footscray Library Car Park at the lower bound, which represents what's the minimum and the maximum number of vehicles going from the data set. And the orange line once again represents the forecasts. Moving on to our third chart. This is once again a modular chart. We do see every single high and low phase of what's the traffic level. Once again, darker theme is heavier traffic, whereas the lighter theme is lighter traffic. Here we do have the weekly average of vehicle traffic at that particular location. Once again, we can hover over to the bar graphs and see what's the value of how many vehicles did pass through. For 1st of April, for an example, 1st of April 2024, we saw there was 3,178 vehicles on average that went by. Similarly, with our 5th bar graph is the hourly average traffic, peaking at which hour of the day was the highest number of vehicles passing by through that sensor. Moving quickly, showing you the data set, which is the traffic with classifications. Here's a quick CSV file with the timestamps and also the values for each of the intervals. It is similar to what is presented on our backend, but categorizing it with lower and higher bounds. Moving on to the backend process, the model actually connects back to a few aspects. The model runs 5 times in this configuration, providing results, saving results in the results folder. If the results folder is not available on the directory, it creates one, and if there is, it releases another folder with all the timestamps. The brand colors that we are using currently is blue, orange, and accent purple to represent our charts. The console and the view holidays are specifically marked out, so we do tend to train our model on the basis of the holidays that were provided by VU. All holidays and locations get into a particular time, start and date time. We have several function modules separated so that it gives a more cleaner version and a faster approach to the charts, with the profit model itself being trained with daily seasonality, weekly seasonality, yearly, with a prior change of 0.1 and interval width of 0.95. Once again, the profit forecast function chart is done by this particular definition. It's specifically chart number 2, which predicts the upcoming traffic with a higher bound and a lower bound. The model also classifies the data sets into the 3 categories of the traffic, which is the cyclist, pedestrian, and vehicle, taking once again the input from the user. We do have the overlay once again where we trained the model with the holiday dates, all the way from timing 12 a.m. to 11:59 p.m. for the entire days. Aggregation chart and aggregation charts are done on weekly basis and on hourly basis. This gives us a more insight view of representing the data sets with training the model. And once again, we save all the interactive graph charts in the results folder with single timestamp. And using the define run, we call the model to run at least 5 times before proceeding the results. And we thank you. We thank you for listening to our project. This is Group Project 17 signing off. Thank you.